Here we have a problem on logarithm. That is, we have to evaluate the given logarithmic expression. Okay, to evaluate the given logarithmic expression, what I am going to do is, first I am going to find equivalent expression for each logarithm we have in this expression. So first, let me take the first logarithm, that is log 16 over 15. So we have log of 16 over 15. Okay, so to find the equivalent expression for this logarithm, I'm just going to use the properties of logarithm. So I'm going to use coefficient rule. So here in the argument of the logarithm, the two numbers are in division. So whenever the two numbers are in division in the argument of a logarithm, what we need to do is we have to take logarithm for the numerator and denominator separately, and we have to subtract them. So we get log 16 negative log 15. And in the next step, I'm going to decompose the 16, the two arguments 16 and 15 into its prime factors. Already we know that, so log 16 can be written as 2 to the fourth power, because if I decompose 16 into its prime factor, 16 can be equated to 2 times 2 times 2 times 2. So we get 4 prime factors, and that is 2. Okay, instead of writing 2 multiplied by itself for 4 times, better we can write it as 2 to the fourth power. So now I have written this 16 in terms of its prime factors, that is 2 to the fourth power. And 15 can be written as 3 times 5. So please make sure the numbers you're writing over here are prime numbers. Okay, so this one can be written as this 4 can be moved in front of the logarithm using the power rule of logarithm. So whenever the argument is exponential, the exponent of the argument over here can be moved in front of the logarithm. So then we get 4 times log 2 negative. And here in the second logarithm, two numbers are multiplied. Here we can use product rule of logarithm. In argument of a logarithm, if two numbers are multiplied, we can take logarithm for each number separately and add them. So then I get log 3 positive log 5. Okay, now in the next step, what I can do is I can distribute this negative sign to this one and this one. Then I'll be getting negative log 3. Negative times positive will be negative log 5. Okay, now I got the expression which is equivalent to the first one, that is log 16 over 15. That is 4 log 2, negative log 3, negative log 5. So in this way, I have to find the equivalent expression for the second logarithm, that is log 25 over 24. Okay, let me do it. So log 25 over 24 can be written as log 25 negative log 24 using the coefficient rule of logarithm. And we have to write this 25 into its prime factors. So we can write as 5 square negative log 24 can be written as 8 times 3. But this 8 is not a prime number. This 8 can be written as 2 cube, because so the prime factorization of 8 is 2 times 2 times 2. So it can be written as 2 cube times 3. So now we got everything as a prime number. So the value of 2 cube is 8. 8 times 3 24. So here I can use the power rule. Then I can bring this exponent 2 in front of this logarithm. I get 2 times log 5 negative. And here two numbers are in multiplication. So we can use the product rule. So we get log 2 cube positive log 3. Okay, now 2 times log 5 negative. So here we can bring this exponent 3 in front of it. Then I'll be getting 3 times log 2 positive log 3. Okay, in the next step, what I can do is I can distribute this negative sign to 3 log 2. Then I'll be getting negative 3 log 2. Negative times positive will be negative log 3. So now I got the equivalent expression for the second logarithm, log 25 or log of 25 over 24. Okay, now let me get the equivalent expression for the third logarithm, that is log 81 over 80. So I can use the coefficient rule first. Then I'll be getting log 81 negative log 80. And here log 81 can be written as 3 to the fourth power, because 3 to the fourth power equals 81, and we got 81 in terms of its prime factors. Negative log 80 can be written as 8 times 10, and further this 4 can be moved in front of the logarithm. I'll be getting 4 times log 3 negative. See here two numbers are in multiplication, so I can use a product rule, that is log 8 positive log 10. Okay, so 4 times log 3 negative, but still we didn't get the numbers in terms of its prime factors. So we can write 8 as a log 2 cube. That is 8 can be written as 2 cube positive. Log 10 can be written as 2 times 5. Okay, in the next step, 4 times log 3 negative. So this 3 can be moved in front of the logarithm. I get 3 log 2 positive. Here in the argument, two numbers are in multiplication. So we can use the product rule. Then we can write as log 2 positive log 5. Okay, in the next step, 4 times log 3. So we can distribute this negative sign to this one. I'll be getting negative 3 times log 2. Negative times positive will be negative log 2. Negative times positive will be negative log 5. Okay, now I got equivalent expression for each logarithm in this expression. So now what I'm going to do is I'm going to plug in this expression for the first logarithm and this expression for the second logarithm and this expression for the third logarithm. So once we plug in into the expression we plug in into the first logarithm has to be multiplied by 7. The same we have to do. That is in the second one we have to multiply by 5. The third one we have to multiply by 3. Okay, so let's do it. Have plugged in the equivalent expression for each logarithm into the given expression. Okay, let's simplify this one. So first, what we need to do is we have to distribute this 7 to this one. Then 7 times 4 is 28 log 2. 7 times negative log 3 will be negative 7 log 3. And 7 times negative log 5 will be negative 7 times log 5. So we can distribute this 5 to each term inside the parenthesis over here. Then I'll be getting positive 10 log 5, negative 15 log 2, negative 5 log 3, positive. So let's distribute this 3 to each term inside the parenthesis. Then I'll be getting 12 log 3, negative 9 log 2, negative 3 log 2, negative 3 log 5. Okay, now we have to combine the like terms. Like term means we have to combine the terms where we have the same argument for logarithms. Okay, let's consider first logarithm. Here the argument is 2. Okay, identify the logarithms where we have the argument is 2. So this one, this one, this one, this one. Okay, here these three logarithms are having negative sign. So first let's combine these three logarithms. What do we get? So negative 15, the coefficient, and here negative 9, negative 3. So negative 15, negative 9, negative 3. So when I combine them, I'll be getting negative 27. That is, when I combine all these three logarithms, I'll be getting negative 27 log 2. And here we have positive 28 log 2. When I combine positive 28 log 2, negative 27 log 2, I'll be getting just log 2 as a result. So I combine this, 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 this. So the result of this one is just log 2. Okay, now let's take the second logarithm. Here the argument is 3. Now let's identify all the logarithms which have argument 3. So this one, this one, this one. So here these two logarithms are having negative sign. So negative 7 log 3, negative 5 log 3 will become negative 12 log 3. And this is positive log 3. So this is 0 pair. So when I combine these three logarithms, everything will cancel out. So we get 0. So this one, this one, this one. Combining these three logarithms, result 0. Okay, now let's take the logarithms which have base 5. So here 5, here 5, and here 5. Okay, so now these two logarithms are having negative sign. When I combine these two logarithms, I'll be getting negative 7 log 5, negative log 5. When I combine them, I'll be getting negative 10 log 5. But here it's positive 10 log 5, so it's 0 pair. So combining the three logarithms here will result 0. So the simplification of the given logarithmic expression is just log 2. Okay, now let's go to the original question. Here we have the original question. So we have simplified the given logarithmic expression, or we have evaluated. So the result is log 2. So the correct answer choice for this question is option C.